Today's lesson is Chapter 8, Lesson 5, which can be found on pages 577 through 582. Our objective is I can determine the common multiples and the least common multiple of a set of numbers. Vocabulary, multiple, common multiples, least common multiple. Question 1. The first step to finding a common multiple is to list several blank of that number. Question 2. To find the least common multiple, you need to find the blank multiple they have in common.
Zoe gets her haircut every 6 weeks. Mia gets her haircut every 8 weeks. How many weeks will it be until they get their haircut on the same week? We can find out by finding the least common multiple, or LCM. First, list a bunch of multiples for each number. Notice how our lists go from least to greatest. Starting at the left, move right until you come across a number they both have in common. You can see that both numbers have 24 and 48 as common multiples. But 24 is the least common multiple because it's the smallest. Since 24 is the lowest multiple they have in common, 24 is the LCM of 6 and 8. That means it'll be 24 weeks before Mia and Zoe get their hair cut during the same week. That's a long time. Another way to find the LCM is to use factor trees to find the prime factorization of the two numbers. First, using a factor tree, list the prime factors of each number. For 6, we have 2 and 3. For 8, we have 2, 2, and 2. Next, find the prime factors that the numbers have in common and circle those. 2 is a common factor for both numbers. That's called a set. A set is a prime factor that is located in both prime factorizations, or in both factor trees. A set counts only once. List all the prime factors, counting any sets only once. So, there's one set of 2, so that 2 counts only once. 2 more 2's, and a 3. Multiply the prime factors you just counted to get the LCM of 6 and 8. 2 times 2 times 2 times 3 equals 24. That makes 24 your LCM of 6 and 8. That's the same answer we got before. Even though there are different ways to find the LCM, the answer is still 24 weeks.
Okay, so I'm on page 577 in our books, and it gives really good definitions up here at the top. And remember, a multiple is a product of a number and any whole number. So multiples that are shared between these numbers are common multiples. And so we're looking for the least common multiple in this case, other than 0. So here's an example. It says Tony hits golf balls at the driving range every 3 days. He practices putting every 4 days and goes golfing every 6 days. If he did all 3 activities today, in how many days will he do all 3 activities again? So if we want to figure this out, we have to find and circle the least common multiple of 3, 4, and 6 by listing the non-zero multiples of each number. Okay, so here are the multiples, and remember they do go on because 3's can obviously go on. So the reason that these are multiples, it would be 3 times 1 is 3, 3 times 2 is 6, 3 times 3 is 9, 3 times 4 is 12, and so on. So that's how you can figure those out. And same with 4. 4 times 2 is 4, 4 times 3 is 12, 4 times 4 is 8, or 4 times 2 is 8, sorry. And you can go on with these. So you just start by multiplying by 1, then by 2, then by 3, and so on. So then once we have our list, we can circle the one that they have in common that is the smallest, the least common multiple, because they don't have 6 in common, they don't have 3 or 4 in common, and 8 or 9. So the next one is 12, and they all have 12 as a multiple. So he will complete all 3 activities again in 12 days because it's the least common multiple. And here's a way that you can check. So you can check it on a number line like this. So they did golf in green, putting, and then driving range. And they showed how he did the driving range every 3 days, putting on the 4th day, golfing on the 6th, and saw when they lined up. So you can do that as well. All right, and here's the factor tree example. So for the least common multiple of 15 and 40, we would find the prime factorization of both. So the prime factorization of 15 is 3 times 5, because we can't break those down anymore. 40, we can do 4 times 10, and then we would break 4 up into 2 times 2, which would be prime, and 10 into 2 times 5, which would be prime. So remember, like that little clip told us, if we have a common multiple, then we only count that once. So the common multiple here would be 5, because they have 5 in common. So we only count that 5 once when we multiply this out. Okay, so now we multiply all the prime factorization numbers besides the common prime factor here. So the common prime factor here was 5, so we only multiply that one time, so we don't do 5 times 5. So we have 3 times 5 times 2 times 2 times 2. And since the 5 we already talked about, we don't have to multiply it again. And that equals 120. All right, so go ahead and look back at these two questions and answer them in the form, please.